Good day. So today we are going to discuss about functions, limits, and continuity. So for the target outcome of this lesson is we will be able, for you, the students, to be able to work on functions. What is a function in the first place? So in a function, the two quantities x and y are related so that for some range value of x, a value of y is being determined. So, if we are going to express a function or an example of an expression of a function, say we have an area of pi r squared and that is the area of the circle. So, in here, a is a function of r. And by looking at the equation, A is the area of the circle and R is the radius. So it means that the area is the function of the radius of the circle. So we can denote this as A is equal to F open parenthesis R close parenthesis, and that is read as function of radius. So area is equal to the function of radius, and that is equal to pi r squared. Another example is we have here y is equals to x squared, and if you're going to recall, this is what? This is a parabola, and y is a function of x, and that is expressed as y is equals to f of x, and thus f of x is equals to x squared. So in a function, there is what we call as the dependent and independent variable. So in our examples above, the dependent variables are the a and the y, the area and this y. Why? Because their values depend on the value of the independent variables r and x. So yung y, ang value ni y will depend on what is the value of x. So the following terms are also worth noting. So such that sa domain is actually the set of all values of independent variables. So say we have a function of x that is equal to 3x squared. The domain here will be any values of x. And for the range, we have a set of all values of dependent variables. So what will be the range? If we have function of f of x, 3x squared, the range would be the value of y or the value of f of x at any x value. Alright, so whatever you put or whatever value dependent variable, whatever the value of x, then you have a corresponding value of y and value of f of x. So to make this more to make this clearer, then we have examples. So for solving the functions, we have a given function f of x is equal to x cubed minus 4x plus 2, and we are going to solve for f of 1, f of negative 2, and f of a. So in this case, our domain will be 1, 2, and a. And if we are going to solve for this function, then we are going to find the range, and the range would be the value of the f of x in a given value of x. So solving for that, if we are going to solve for f of 1, we just directly substitute the values of x, such that for f of 1, we substitute x is equal to 1. And thus, we substitute x equals to 1 into this equation, and so we have f of 1 is equals to 1 cubed minus 4 times 1 plus 2, and we have an answer of -1. This would mean that if y is equals to f of x, given that f of x is equals to x cubed minus 4x plus 2 at x is equals to 1, the value of y is equals to -1. Alright? So for our next example, we are going to solve for the value of f of -2. So again, we directly substitute that to the given function. So we have a -2 cubed minus 4 times -2 plus 2. And so we have 2 as the answer. And then we have another variable. We have f of a. So we just substitute a to x. And thus we have a cubed minus 4a plus 2, and we have this as our answer. So, why are functions important when it comes to calculus? In here, we are going to translate any verbal problems or any physical problems into mathematical forms or mathematical equations. So that is why we need to learn the art of how we are going to translate the problem into a mathematical equation. So we have here an example, and it says that the area of a rectangle is 6 square inches, and we are going to express the perimeter P of the rectangle as a function. Say perimeter P of the rectangle as the function of the length x of one side. So meaning we are going to find what? We are going to find P of x. We are going to find that one. And if you're going to draw the rectangle, we have this rectangle. We assume W and on one side, and we assume this as our x, and that we equate that to x. And we assume another side, the longer side, as L. We are given an area, and the area is length times width. And so we can transform L into a function of the other side. So we have A over W, and W is equals to X, and thus we have A over X. But we are going to find the perimeter as a function of the length of one side. So we are going to find P of X. So in a sense, what is the perimeter? Perimeter is actually the total of all the sides. And we have here 2L plus 2W. So we have 2L and 2W. And substituting the values, that one and this one, to our perimeter. Formula of perimeter. We have P is equals to 2L plus 2W, and so we have P is equals to 2 times what is L? We have A over X plus 2X, and so we have P is equal to 2 times 6 over X plus 2X. And thus, we have P is equals to 12 over X plus 2X. Simplifying this further, we can have several answers. So we have P is equals to 6 times 6 over X plus X, or P is equals to 2 times 6 over X plus X squared over X, or P is equals to 2 times 6 plus X squared over X. So these are all the same. So those are all correct. So meaning we can express P of X is equal to 2 times 6 plus X squared over X. And this is now the answer to the problem.